Hi dear grade 8. Our lesson for today is about combination. A combination is a selection of R objects from a set of n distinct objects in which the order of arrangement is irrelevant. So meaning here, the order does not matter. Unlike with permutation, where the order of the R chosen elements is important. Now, class, the number of combinations of n objects taken at R at a time is denoted by the symbol. So this is our notations whenever we solve for combination. And this is read as combination of n taken R. Deriving a formula for the combination of n objects taken R at a time can be derived from the formula for permutations. So by definition again, a permutation of n objects taken R at a time can be obtained from a combination by arranging it in any specific order. So since there are R factorial such arrangements of the said objects, it follows that combination permutation of n taken R is equal to combination of n taken R times R factorial. So dividing both sides by R factorial, so we will yield to combination of n taken R equals permutation of n taken R all over R factorial. By substituting the formula for permutation, we have combination of n taken R equals n factorial all over quantity n minus R factorial times R factorial. So this is the formula that we will be using whenever we solve for any combination problem. So let's work on each problem here. How many combinations can the 7 colors of the rainbow be arranged into groups of 3 colors each? So we know that our n here is 7, represented by the 7 colors from the rainbow. And then we'll be selecting 3 colors. So our R is 3. So combination of 7 taken 3 is equal to 7 factorial all over 3 factorial times quantity 7 minus 3 factorial. And will lead us to 7 times 6 times 5 times 4 factorial all over 3 factorial times 4 factorial. So canceling 4 factorial on the numerator and denominator, and we know that 3 factorial is 3 times 2 times 1, and 3 times 2 times 1 is 6. So we have 35. Combination of 7 taken 3 is 35. So there are 35 combinations. Can the 7 colors of the rainbow be arranged into groups of 3 colors? How many lottery tickets must be purchased to complete all possible combinations of 6 numbers, each with the possibility of being from 1 to 49? So here, order does not matter, and n is 49. And since we will be selecting 6 numbers, so R is 6. In the Lotto draw class, in the Philippine setting, we have Lotto 149, Lotto 142, 145. So here, it's like you're going to select 6 from combination of 49 numbers from 1 to 49. And again, order does not matter here. So combination of 49 taken 6 is equal to 49 factorial all over 6 factorial times 49 minus 6 quantity factorial. And this is 49 times 48 times 47 times 46, 45, 44 until 43 factorial all over 6 factorial times 43 factorial. So canceling 43 factorial and 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So simplifying the expression will come up with 13,983,816 six number combinations from 49 numbers. Imagine if you're going to like bet for all these combinations, and for instance this is approximately 14 and per bet is 20 pesos. So you would invest 28 million and the jackpot price would not start from 48 million. I guess this will start with a single digit, approximately 8 to 9 million. Okay? So for number three, how many groups can be made from the word house if each group consists of three alphabets? So our N here is 5 and our R is 3. So combination of 5 taken 3 equals 5 factorial all over 3 factorial times 5 minus 3 quantity factorial. So this is 5 times 4 times 3 factorial all over 3 factorial times 2 factorial. So this will be canceled and we know that 2 factorial is equal to 2. So this will be 2. So we have 10. So combination of 5 taken 3 equals 10. Now, Maria has 6 chocolates. All of the chocolates are of different flavors. She wants to give 2 of her chocolates to her friends. How many different combinations of chocolates can Maria make from 6 chocolates? N is, so N here equals 6 while R is 2. So this is combination of 6 taken 2. So we have 6 factorial all over 2 factorial times quantity 6 minus 2 factorial. So this is 6 times 5 times 4 factorial all over 2 factorial times 4 factorial. So canceled. We know that 2 factorial is 2. So this will be 3 and this will be canceled. So 6C2 or combination of 6 taken 2 is equal to 15. So how many lines can you draw using three non-collinear points? So when we say non-collinear, the 3 points do not belong on the same line. Okay? So for example, we have points A, B, C on the plane. So if like this is point A, this is point B, and then this is point C. Okay? And this is about and order does not matter here. So how many lines can we draw to this from the distinct points here? So if we're going to connect A to B, so we have AB here, okay? And then B to C, we have BC, and then A to C, we have AC. So we have three lines. We can draw three lines, okay? Take note that order does not matter here when we say line AB, it's the same with line BA, as well as BC, it's the same with CB, and so with AC, the same with CA. So using the formula, this is combination of 3 taken 2. So we have 3 factorial all over 2 factorial times 3 minus 2 quantity factorial. So this is 3 times 2 factorial all over 2 factorial times 1 factorial. So this is cancelled, and we know that 1 factorial is 1. So we have 3. And these are the three outcomes: AB, BC, and AC. Now, for this problem, is it permutation or combination? In number one, Mr. Chu's responsibility as a basketball coach is to choose his starting lineup for each game. So if his team has 12 players, how many ways can he select a starting lineup of 5 players? So here, order does not matter. So in the given situation, Mr. Chua will just select the starting 5 players. So without considering anything. So this the order does not matter here. Players are chosen in random order. So this would mean combination problem. So we're going to use combination formula here. And substituting the given n equals 12 and r equals 5. So we have combination of 12 taken 5. So we have 12 factorial all over 5 factorial times quantity 12 minus 5 factorial. Working on the difference on the second factor here. So we have 12 factorial all over 5 factorial times 7 factorial. Expanding the 12 factorial until 7 factorial because there's this 7 factorial on the denominator. And then canceling both 7 factorials here. So we got this value. And we know that 5 factorial is 5 times 4 times 3 times 2 times 1. Simplifying the value will come up with 792. So there are 792 ways can Mr. Chua select his starting lineup of players. Now in number 2 class, each player in a basketball game plays a different role. For instance, we have center, power forward, small forward, point guard, and the shooting guard. Now, if Mr. Chua would consider the position or the role of each player, how many lineups are possible? Now, since each player will now be assigned to a specific role, the order in which the players are chosen becomes important. So, order matters here, class. So, that indicates that the problem involves permutations, and thus, the number of possible lineup is provided by this solution. So, take note here again that n is 12 and r will remain 5. So we have permutation of 12 taken 5. So substituting the given in the formula, we have 12 factorial all over quantity 12 minus 5 factorial. So we'll come up with 95,040 ways of choosing the possible lineups if he will consider the position by each player. So again, permutation in permutation, the arrangement matters or the order is necessary, while in combination, the order or the arrangement is irrelevant. So that's it for now, grade 8.